other two with pure storage?
With Christie.
Yes.
Okay. Yeah, that's a different story.
Portals is nice concept.
It's top notch, yes. I do them on a Portals as well. It works really well, and it does everything you would need in a Kubernetes. It's really good. I think I will start because it's almost 05. So thank you everyone for coming. Once I had a session, I think like 6-7 years ago, which was the 5 p.m. session on the second day. I had 3 people standing here, and I think I was talking about object storage. So what was not the friendliest thing for the last session. My name is Jacek. I work for Pure Storage for 2 years, and I'm in like 25 years in IT, most of them in storage. And today, as you can see, I have 0 PowerPoint slides, so there will be no next PowerPoint presentation. I will demo things. Okay. So if you are surprised now, I'm not offended if you leave or something like that. What I'm going to do is I have 2 arrays in our Prague lab, which we typically use for ActiveCluster demo. ActiveCluster is our 2-site active-active synchronous replication technology, and I will do the demonstration using VMware environment. I know it's everybody is looking for an exit plan, but still is the most used infrastructure solution. So I will use this. I will put together everything by hand using the GUI on both the flash array and the vSphere. And then at the end, if we still have time, I will show you like ideas for automation. I'm a really big fan of automation, so I brought a little bit of shell scripting and Ansible today. Okay. So what you see right now, is there anyone who knows the flash array? So we start from 0 on the Excel. So what you see now is the typical dashboard where you land when you log into a flash array. So I guess this is similar to other storage arrays dashboards. You have basic performance and capacity information on the dashboard. And you can see that I was playing in the morning, so there are lots of alerts that things went offline and things like that. We will do that in this next 45 minutes as well. So I will kill this to show you that how it behaves. I have 2 arrays. I'm sorry, I will sit down because although I prefer to go back and forth, but I cannot really do a demo like walking. So I will sit down. Very low. So I have 2 arrays, A and B. This is the A, and this is the B. And you can see there's a subtle difference between the 2, that this guy has orange and this doesn't. Okay? So the difference between the 2 is that A has workloads which are not synchronized, and the orange ones are basically the local writes. The purple line is the mirrored writes, which writes to the local storage and the remote array as well. So that's the difference. On the B array, we don't have any workload that will write locally, so it only has mirrored data. On the A, we have things we mirror and we have things we don't mirror, so it has both of the words. Okay? So what I'm going to do is I will not go through like a walkthrough of the GUI. You will see everything. What I'm going to do is I will create a volume. Like standard things, I will create a volume, I will map it to my vSphere cluster, I will bring it up as a data store, and then we will mirror it and so on and so on, and then we will look into failures, okay? So I will go, before that. So these 2 arrays are already linked together. So the very first step, what we need to do is that we need to do a handshake between the 2 arrays, which is already done. So normally that would be done from the production, from the protection. You see that there are already array pairs here in the protection. So the A array sees the B and another one, which we don't use in this demo. and the B array can see the A, and it sees that, okay, we are using Ethernet for replication. We can use either Ethernet or fiber channel, we don't care. So whatever you have, it's fine for us. It's not encrypted, you could encrypt the replication traffic, and it's set up for synchronous replication, okay? Normally, connecting the two arrays works in a way that on any of the array, you take this menu, you get the connection key. We really like public key authentication. So we would generate a key that's right now going on, so I'm not going to wait for this. You copy the key, you go to the other array, and you say plus. You paste the key here on the management address information, and that's it. Once you do this, the arrays are connected, and basically that's it. So typically, like, if you take and if you're interested, I can send you an invitation to our lab. We have a web-based lab. We do virtual arrays and things like that. You can try all of these. So typically, like connecting together two arrays is like 3-4 minutes maybe. If you are faster, then you can do it under 1 minute. Okay.
Which is the minimum bandwidth for the cluster to be?
It's a very good question. Kafka, we have a question, I'm just saying. So it's a very good question. The minimum we would recommend 10G. We don't even have other ports. So the replication ports we have for IP, we have a 10/25 port. For fiber channel, it's a 32/64. We ship it with 32 SFPs, so you can go down to 16 or 8. So the fiber channel is anything between 8 to 16, or IP it's anything between 10. Currently it's 10/25. We do have 100 gig ports, but we cannot use them right now for.
With 10 is still reliable.
That is absolutely. At the end of the day, it's going to be based on the bandwidth between the two arrays. And we would recommend 2 ports per controller, so there's 4 per array. So you are going to have quite enough bandwidth for the application. Okay, so I'm going to create a volume. In pure creating a volume is quite easy. You give the name and the size, and that's pretty much it. So I will say my initials and AC demo, and I will create a 120 gig volume. And basically I will click on the volume and I will connect it to a host group. So I right click here, I select the one, this is the cluster I'm using, this is a vSphere cluster, so it's a host group having multiple ESXi nodes. So once I'm connected, it's connected, I got the LUN ID of 251, and now it should be available on the vSphere side. So classic thing, I go to vSphere, first thing I'm doing a rescan. So it scans the storage for, for new things. And once that's done, I am going to create my data store. I will use the same name. And I need to select one of my hosts for scanning. And I see my 120 gig volume, so I will just use this, and I will just go and use all the defaults. So first up we have, and we have the volume called AC demo. So now if I go to my VM view, I have the host selected, I have all the storage devices, so we can look into the paths. So I will look for my newly created volume, selected, and I will check the path. Currently I have 6 paths. It's a little bit weird configuration. I think was something we are missing on the zoning, because in this one we have 3 ports per controller, so that's why it's 6. I need to ask my colleague to check the zoning because I don't have access to that one, but I'm using like this, and it's okay. Of course, it's a demo environment, so sometimes we are also facing with bugs, but it's 3. Normally, in production environments, you would probably see 8 here instead of 6. Okay. So, what we are going to do now is we are going to stretch the volume between the two storages. So right now, what we have is we only have it on the A array, so I'm going to stretch it between A and B. The pure storage active cluster is an active-active, so what's happening basically, both storages will serve the same volume with the same serial number to the ESX hosts. So the ESX host will just think that hey, is the same volume, it's just more paths. So what we will see on the ESX side is that we will go from 6 paths to more paths, and it will be basically the same volume. So for this, what I need to do is I need to create a pod. A pod is basically a consistency group. We call them pods. In a pod, you can have one or multiple volumes, and when you stretch them, it will stretch all of them, and it will keep them consistent. Okay. So what I'm going to do now, I will use the same naming. So I will use the AC demo. Here you can put quotas. So if you provide pods for colleagues, then you can put a quota on this, so they cannot put more than, I don't know, more than half a terabyte or more than a terabyte, or depends. So the whole array supports role-based access control. So you can create storage admins. I'm an array admin, so I'm Joker, I can do anything. But you can create array storage admins, and storage admins would not be able to create pods. They would be able to create volumes, so put it into the pods, and you can limit their access. So now I have this AC demo, and what I'm going to do, I will move in the volume I created, and which is currently connected to vSphere, and I will just move it. It's already very, very visible because the name of the volume changes. So even if I go back to the volumes view, now the name of the volume is AC demo, and we use a double semicolon between the pod. So we use pod name, volume name, and it's useful because if you automate the things, then you can use this to refer to volumes. So for example, when you have stretched volumes and you want to clone them, for example, for databases, you can say that, hey, I'm cloning it to pod name, volume name, so that it stays stretched inside a pod. Or you can say that, hey, it's a volume for dev, and I'm just cloning to volume name, so that will be outside of the pod on one of the sides. Okay? So now what we did, we moved the volume inside the pod, but the pod is still only on one array. So what I'm going to do is I'm going to stretch. So I will select the B array, and click on add, and basically it's going to sync. It's pretty much an empty volume, so I expected it to sync really, really quick. And then we can check how the paths are working in this way. Also, if now I check it on the B, and if I check for pods, I see that this AC demo appeared here, and we have a resyncing event, and then once it's finished already, then what I need to do is now I have the volume on the second array as well, so I also need to map it to the host group. Okay, so I will connect it just like in the previous case to my one cluster, and now I am ready to check the paths on the behaviors. So let's do rescan. Rescan all the things. And before I click on the rescan, you can see that okay, it's 14 now. So the number of paths now it's 14. The reason it's 14 because the second storage is done properly, so it has 4 per controller, so 8 paths. And the first storage is not done properly, so it only has 6. So altogether it's 14. And what's also you need to look into that every single one of the paths are active IOs. All of them are serving IOs. So this is the default behavior of the active cluster, that they are equal. So typically when you would have like the metro location, which is like very close to each other, a couple of kilometers, maybe 10, 20, then we would leave it like here, because on fiber channel, having 20 kilometers is negligible in terms of latency. So you can take all the paths equally. And VMware will just use the PSP round robin to round robin between the active paths. Okay? So now we have an empty data store. It's stretched between the two sites, so I'm going to create a couple of VMs on it. For this, I'm going to use Ansible, and I have a clone VM script, which doesn't do anything. I have a 30 gigabyte Windows template, and it's cloning over this data store. So you see that I started to clone for my Windows template into virtual machines. And once my first template is done, I will actually log into and I will start an IO meter. So we will see that when I break one of the storages, we will verify that, okay, we are still writing and there is no outage or nothing like that. So my VM is ready. So I will start my VM. This is Windows 01. I will not the remote one, because that one I don't like, I don't that one. So this is the point where I usually fail, because I often forget the password of the Windows VM. I was okay this time. So I have the IO meter. I will just start a very basic workload with two workers, both just writing the C drive, 50-50 read and write, and I will start it. Okay, and I will change the monitoring to 1 second so we actually see that it's writing. Okay, it's writing. So we have a 5,000-6,000 IOPS coming out from this VM. So this will be our verification point. When I will break things, we will come back here to make sure that is this still up, is this still writing, is this still okay. Okay, it's not an Oracle database, but still. Okay, so let's go back to my vSphere and let's check what's going on. So let me check my data store. So what you can see that I only cloned like 2 or 3 VMs, but my data store is actually filling up, and you see I got an error message. It cannot clone any more VMs. I started the script to clone 10 virtual machines, and after like 2 or 3, basically filled up. I got a lot of this question from customers that, okay, you have a stretched volume, so how you resize it? Because there are a lot of storages on the market. You need to break the replication, resize the volume, and then replicate again. For us, it was built in mind of that, because so our main advantage is that we started late. Okay, so the whole company started in 2009. Our ActiveCluster started in 2019. So we know what other companies failed, and we came with the mindset to fix all of those. So for us, the resizing a stretched volume is as easy as I go to the volumes. I select my stretched volume, which is currently, if you remember, it's 120 gigabytes, and I'm going to resize it. And let's say I will take 890 gigs. The reason I'm using these weird numbers, because then I can recognize the volume in vSphere, because my colleagues tend to leave the leftover volumes, and I just want to make sure that this is my thing. So I did the resize. So now I can go back to vSphere, and I can right click on this and says increase data store capacity. It's still 120 because I forgot to scan it. So let's do the rescan. And Ansible is still trying to clone. It just tries it because it's a reliable thing. So, and you see that I already got an alarm that it's filled up. So let's resize it. Now I can see I'm 890 gigabytes. So I'm increasing, keep the default value. So I will just increase it to 890 gigabytes. The resize happened. So I have 800 gigabytes free, so let me check my Ansible. It failed, so I will restart it so the clone will continue to go. Okay, So we did resize, we did the stretch. So what we are going to do next? Okay, let's do a couple of type of failures. I brought two type of failures. So I was always thinking that, okay, how should I fail the storage? Because normally when we do this testing in person, what we do is obviously we pull out the power cables. So the equivalent of that one would be going into the storage and shut down the system. But we don't have shutdown command in Purity because the normal shutdown of the system is pull out the power cables, but I cannot go to Prague now to pull out the power cables, so I need to figure out something else. So I created two failure scenarios. One of them, I will disable all of the 5HM ports on the B array. So it's like a fabric failure, like a double fabric failure. And the second failure scenario I bought, I will cut the replication traffic between the two arrays. So this, basically when you cut the replication traffic between the two arrays, what happens is that they think they both failed. And this is the point when you realize that, okay, we need something like a quorum. And we do have a quorum. By default, when you create an active cluster, we provide you with a quorum. So majority of our systems are connected to Pure One, which is our cloud-based proactive support system. And within Pure One, we provide you with a quorum. So what happens is when you cut the cable between the two arrays, they do a race to the quorum to ask that, okay, am I first? Because if I'm first, then I assume that I survived, right? So if the answer is yes, then the pod is going to be survived on that location and the other one will fail. Okay, so first let's do the front-end failure. I will use another window for another script, and I will do the fail b.sh, which is basically failing the front-end ports. Okay, so I have a lot of front-end ports. I failed all of them. First check, we go back. We are still writing, good. And then let's check the paths. So I go to one of my ESX. I will search for my data store. Here we go. And I have 6 paths remaining. So I failed the B array, which had 8, and now I only have 6. Okay. So if you say that this test was passed, then I will go back and I will do unfail, because I also wrote an unfail script, and I will do the unfail. And now you will see that I was lazy because I wrote one unfail script for both of the failures, and it will unfail both of the scenarios. I like to simplify things, so if I can write one script, I will write one instead of 2. So now if I go back, I'm supposed to see back, yes, exactly all the 14 paths, okay? So I have all of them available again. My cloning is still going. How many VMs I have? Now I have 8 VMs, pretty good. And the IOPS is still going. So let's look at the other failure, which is basically failing the replication traffic between the two arrays, okay? So for this, I have a fail REPL sh, which will basically disable the replication ports on the B array, so that's cuts the traffic between the two. So let's see what we see now. First, let's check the array, the pods. You see that all of the pods has a lot of reds. And now what we see that some of the pods are online on the first array, so they failed over here. But there is one pod which probably failed to the other side, yes. So this vVols pod, it failed to the B array, and all the other pods failed to the A array. So we actually do the race and the failover decision per pod. And the reason we do that, because you can actually set preferences, and I will show you how to do this. So you can say that, hey, my Oracle databases are on site A, so I want my Oracle pod fail there if I cut the traffic. And all my MySQL is on site B, and my MySQL pod I want to fail to site B if I cut the traffic, so they can continue to work locally. So that's the idea behind. So we don't fail over like the whole array and good luck recovering it. It's per pod, so it's very, very granular. Okay? Let's check the VMwares.
And if you don't
Yes?
put any reference,
Then it's
it's
per pod.
Load balance failure.
So every single pod races to the column. We'll check MI first, and if that side is the first, that pod will be on that side. So both arrays for all pods will start a race. And for
which is the criteria to be first considered?
to just get there first. Okay, so let's say you have a pod which runs on both arrays, and we have right now we have the column in the cloud. So they both go very fast. I mean, they are in the same rack in Prague, so the chances are pretty equal, right? I mean, if you are in Germany and let's say we have this in Frankfurt and one of your side is Frankfurt, the other one in Munich, then probably the Frankfurt one will have. And we can also provide you like an on-site quorum. So we have a VM, you can deploy the VM, and that's going to be your quorum. And this one you can actually configure per pod again. So for some of the pods, you can say that, okay, I will keep the pure default one. Some of the pods, I'm going to deploy my own. Okay, so that's how it works. So let's check the paths. So what we have here, we have.
I think here in Romania it would be much better because we have something like one line, it's DG communication, like it has 90% of Romanian, so it's like a big metro.
Yes. To be honest, out of all of my customers, I think 2 of them using the mediator, what we provide. And since I joined Pure, I think I've seen 1 mediator failure, outage in the cloud. It took like 2 minutes maybe. So it's a pretty good availability, I would say. So I can see that some of my paths are dead and some of them are active. Okay. So now what I'm going to do, I will do again the unfair. So this should come back. If I go back to my storage, let's do refresh. Yeah, they are resyncing. Some of them barely have traffic, so it's already back. Mine actually has traffic because if you remember, we have this VM. Let's see where did this go? Okay, this was Win1. And then we have console. Yeah, it's still writing. I also have DRS, so sometimes the VM would move between the ESXi's. Especially we use this environment pretty heavily. So if you look at our ESXi's, the memory is quite stretched on both nodes. So we paid the whole amount of memory, so we like to use it. Okay, so let's do the next thing. So what I'm going to do is that I can fine-tune in multiple ways. So as you said, all the paths are active I/O. So that's the default behavior. So for this, what I can do is I can set up preferred arrays on the hosts. What it means is that if you have a longer distance, let's say, as I mentioned in Prague, we have it in the same rack. Okay, so I don't mind which one I'm writing to. And also if you have like 2 sites within Timisoara, or if you have 2 sites, like let's say one of them in Orad, one of them in Timisoara, it's pretty close, you don't care. But let's say you have like a longer distance, like Timisoara to Cluj, for example. If you take that, it's a little bit longer distance, so you don't necessarily want to get to all paths, because the one that goes to Cluj will be a couple of milliseconds to return. So what you want to do is that you want to tell the array that, okay, which one I prefer, so which of the hosts is closer to the array. So for that, what we are doing is a host-based setting. So obviously, it's a physical setting because I know that physically which host is located closer to the array. So this is something I need to do on the physical host. So I go to the host setting, and I will go to the cluster 1, and say what to do. So what I'm going to do is I will set the B array as preferred. So the B array will have the active I/O. The A array will be just active and not doing any I/O, okay, on the front end. And I will fill the B array, so we will see what's happening. So what I'm going to do is I will open up the host, and you see the preferred array is right now it's empty. So I will say add preferred array. I will put in the B, and I will do this on the other host as well. The B, all right, and I need to do exactly the same thing on the other array as well to have it consistent. So I go to hosts, I go to cluster 1, host 1, preferred array B, and then the same thing on host 2 as well, preferred array B.
Now the replication will be backward from B to A now.
So, I mean, it's always, because till now it was completely random. Thank you. It was completely random. So some of the bytes you wrote to A, some of the bytes you wrote to B, and the one you wrote, it went to the other side, acknowledge back, right back. Now every single byte goes to B, replicates to A, get back the info, confirm it back. So now I should see that my paths, and let's find it again. Where is my path? It is here. So I think I need to do rescan. So storage rescan. I still have 14 paths, which is good, but I should have half of them. Now it's thinking. So let's find it again. It was done, thank you. I wanted to ask you if you see it, please yell. Now you see that, okay.
Much larger.
Yeah, so now you see that some of them are active I/O and some of them are active. So let's kill the one that provides the active I/O. I will again use the fail B, which is going to kill the front end on the one that provides the active I/O, and they immediately disappear. And they disappear, and once I have all of them disappeared, then basically the active ones will just change into active I/O. And my VM is still doing pretty well. So let's do the unfair. And then the other thing I'm going to show you is that, so the previous test, let me clear very quick the host configuration I did. So it was hosts, so again hosts, 1, this, remove, yes, map, this, remove, yeah. I think I should automate this one for the next demo. That's my feeling. This one, at least the removal part, because now it took me like almost a minute to remove all 4. Okay, so we are back to normal again. We should have 14 paths. Let's do rescan. And while it rescans, I will tell you what I'm going to do next. So what I'm going to do next is I will select my pod, and I will tell my pod that, hey, I want you to fail over to the B. We will cut the connection between the two sites, and we should see that it fails to the B side, okay? So my ports are back, all 14, everybody is active I/O. So let's go here. So what I'm going to do now, I will take my pod, this AC demo pod, pod, and I will add the failover parameters. And I'm going to say that, hey, I want this to survive on B. Okay? I did that, and there's nothing visible from this perspective because what it does is actually when there is a failure between the connection, the B will get, I think it's like 2 seconds advantage. So when it gets there, if the A gets there first, then hey, just wait a little bit, we need to wait for B. So I will fail again, but now I will fail the application. And let's see if it works. If I go to pods, okay, this one, pods. So let's see, the AC demo is online here and it's offline on A. And the other ones are kind of mixed. I see one which failed to the A and a lot of them failed to the B. Okay? So with this you can actually, if you have 2 sites, but the applications are kind of local to one site, you can force it that in case of a replication network failure, then you can change the behavior where it should have. So let me think what I didn't show you. I think I show pretty much everything. Obviously, yeah, so what's very important is that based on the behavior you see that there's nothing VMware specific here, okay? So I didn't use like a VMware plugin or anything VMware specific. So if you have, for example, I don't know, bare metal Oracle host, thank you, or I don't know, Linux servers or anything, it works exactly the same way because on the host side, what it does, it has the volume, what you see, you just have multiple paths, and it's the multipathing driver. And we also don't give you like a specific multipath driver that, hey, you need to go on every single host, you need to install this. We just work with the operating system default. So what we are trying to do is that on the front side and on the host side to make it as simple as possible. And just not have like manual configurations because usually if the storage you have 2, maybe 4. With larger customers I see them like 10. I have a specific one who has 36 storages, but it's their problem, not mine. But normally hosts you have a lot more. So we want to avoid that you need to go like 100 hosts and change settings just because of us. So we keep everything on operating system. So I have 2 more leftover things. So you can do everything what I show on the command line. I'm not going to do this because it's kind of tedious that you all watch me typing commands. But what I'm going to do is I'm going to build 2 more pods with volumes inside each. With one of them I'm going to use a shell script. So this is the, and I'm going to show it, is the AC shell, if I remember correctly. Yes, this is the one. So it's just the command. So pure pod create, pure pod stretch, pure volume creates, and so on. And then I map the volumes. The point here is that that you can do all of these automatically. So if you have a dynamic environment when you need to create these pods, maybe sometimes cloning them, because we also have that capability that you can take a full pod and clone it and give it to developers, for example. But it's quite a dynamic environment. So you can do it with an easy script. And if I go back to my pods, now I have a test 2 pod which have 3 volumes that I created now, which are mapped to a Red Hat host, every single one of them. And this was basically a shell script, and these are connected together, so they are both online. And you can do all of the settings. So I could add like the preferred site setting, or I could do any of these settings. And you can do this also with Ansible. So with Ansible, I'm going to create a test 3. And this does the same thing, just the output is different because Ansible looks different when you run Ansible scripts. But if I go back to my pods, now I have an an Ansible one, and it has one volume, which is, why is not that? Maybe I forgot it. Yeah, I mapped it on one side and forgot on the other, so I need to add one more line to the script. But the idea here is that you can automate the whole thing. If you have development teams, we have also an SDK. I have colleagues using it heavily. I also use it with Python. So if you have, if you need to like speed it up, you can write Python automation. We have a pure plugin. You import the plugin, and from there we can create everything: create path, create volume, do the sync, everything. Any question? Was it clear? Okay. You disagree in the back. Probably because you are very far away and you didn't
No,
see
I'm
my
just
post.
new to the whole storage thing, and that's why I said that.
Okay.
For me, it was the most interactive.
Okay, thank you.
Yes, that I can agree with this.
Never had the demo failure with more than one type of failure.
I can tell you I failed it yesterday like 3 times and even today once. And then I figured out what I did wrong. But yes, I did polish it quite sometimes. To be honest, I like things that can be automated. Yeah, we have done, thank you. So I like things which can be automated because especially, so when I was young and when I did admin jobs, we didn't have the issue what you guys have now, that we didn't have enough people. We had like, like 2 times more people when we needed. I've seen, sysadmins sleeping on the desk and stuff like that because nobody cared. But now it's typically pretty much everybody is overloaded. So the more you can automate, the more you can actually control everybody.
Yeah, it's nice. You can do it with cron jobs.
Yes.
It's perfect. Like doing in the night or something like that, like sleeping.
So now I have the tough point because I only have 4 buttons and it's you got 1 and it's 5 extra of you. Actually, we can give away the 4 and I think we should have 1 more in the booth. We don't.
It's okay. It's okay.
Okay. I mean,
I have my bottles, so it's okay.
so thank you so much for coming. So obviously we have local, you can find us. We are still in booth till the end of the conference, and thanks a lot for watching me trying to show you something.